the block and your wife was in the car.
Yes, good morning, children. Shall we start? Yes. Yes, children. Just this is, I think after 1 month you have again your classwork. So if I go for the new topic, then you may forget these concepts. Then just I will recall the previous class concepts once again. Yes, please. Children, yes, please try to understand just whatever I told in the last classes. Just I will revision it. Please try to understand their concepts. Right? I think I asked to implement these programs. I think you may or may not implement that programs. So I will show the execution of the programs at the same time. So I will revision the topics. Right. So now, children, anyone can tell what are the different algorithmic strategies? Yes, please. Yes, children. Yes, children, anyone can tell what are the different algorithmic strategies? Yes, please. మాట్లాడండి. Yes, Uday Kiran. Yes, please. Children.
Brute force.
Brute force. Yes. Karthik, any other?
Divide and conquer.
Yes. So now the different algorithmic strategies like brute force technique, right? So next is divide and conquer strategy. So children are able to see my word document. So now I will share this content. Okay. Yes. So now, so new share view people admit all. Yes. So just these two classes I will go for this revision only, right? Share. So my word document. So now we are talking about the different algorithmic strategies. What are the different algorithmic strategies means? Brute force, divide and conquer strategy, greedy approach, as well as dynamic programming, right? So these are the different algorithmic strategies, right? So now, can you tell before going to these different algorithmic strategies? So first of all, you need to analyze this graph. This graph is very important, right? Suppose if some algorithm is fall into any one of the above categories, right? So now you try to reduce the time required to evaluate this algorithm, right? So one is this a constant time log n base 2 square root of n. Yes, the algorithm needs a square root of n here. So next one is here it is n, a linear time complexity, n log n square, n cube, 2 power n, exponential power complexity is non-polynomial problems. So n factorial, right? N power n. So next is n power n factorial. So this algorithm is yes. So actually, what is our intention? So if there is any algorithm, it must be any one of these time complexity category. So if it is fall down in this category, you try to apply your mind, your heuristic. Heuristic means previous experience and knowledge. Then by using this one, so then you, so am I recording? Yes, children. Now admit. New share. Yes. Resume share. So where I recording? Where is this recording? Stop share. Yes, stop. Yes, recording is on. Okay. So share. So this. So now, children. So this diagram, you try to remember this diagram. So if some time algorithm is in linear time complexity order of n, then you try to reduce below of it, right? So this is a strategy. So you can take this algorithm, copy this algorithm. We need to go for our paint. Yes, file, paste here, file, control V, paste. Okay. Children, so this is entire picture, entire our subject is, so this one only, right? So what we are doing, yes, I will share my screen once again. So this one, screen, untitled paint, right? So now the time complexities, I will draw a diagrammatical representation. So on x-axis, I taken this n, the problem size n, that is number of variables for the given problem n, right? So now this is problem size n. So next we will take the time required to execute your algorithm is this one, capital N, right? So now what I am trying to do here is this is a constant time. So next one is a logarithmic time. So the square root of n, yes. So can you tell some of the algorithm where we are applying the square root of n? Yes, children. So where we can apply the square root of n algorithm? Yes, anyone can speak out, children. So where we can tell this square root of n algorithms, right? So now here you take this prime numbers. I think you are implemented this prime number logic now. Prime number logic. So anyone can tell what is prime number? A number which is divisible by number which is divisible by one and itself. Right? Itself, a CLF. So this is a number which is divisible by one and itself is said to be a prime number, right? So in another way, a number which has contains only two factors. A number contains two factors. In this strategy, suppose if you want to find whether the given number n, suppose n value, I want to know this, I want to check this number is 9, whether it is a prime number or not. So what is our strategy? We need to apply 9 modulo by 1, modulo division by 1 equal to 0, first step. So next to 9 modulo division by remainder 2 equal to 0. So up to so on. So up to so on 9 modulo division by 9 equal to 0. So now if it contains only two factors, then it is prime. If it contains two factors, number of factors is 2, then it is prime. Right? So not prime. It is number of factors is 2 only, then it is prime, else not a prime. So this is the simple strategy here. It is, children. So now what we can do here it is, so simply suppose if you want to check a number is prime number or not. So actually here numerator part is 9. Yes. So children, you make one observation here. The numerator part is only numerator by denominator. This part we are taking numerator by denominator equal to 0. That is so we go for this modulo division operation. Modulo division operator will give the remainder. If the remainder is 0, then we can say that remainder. If it is remainder, if remainder is 0, then we can say that so that is divisible by this one. That is a factor. It is a factor. Yes. If it has two factors, then it is. So what we will do? So numerator part is same. In denominator part, we can go for 1, 2, 3 up to so on 9. Right. So denominator part is started at 1. So 1 to 9. Right. Is it required to evaluate these many number of steps? If possible, try to reduce the number of steps. Children, if possible, try to reduce the number of steps. So by applying some heuristic or simple mathematics, so you try to reduce the number of steps. So for that purpose, what we can say that, so I'm starting at 9 modulo by 2, right? So equal to 0, the first step, right? Double equal to 0. So next 9 modulo by 3, right? So equal to 0, double equal to 0, up to so on. What I can do? So 9 modulo by 8. Yes, 9 modulo division by 8 equal to 0. So that means 1 and itself I am removing. 1 and so 9 in denominator part I remove. So if you are removing this one, so you need to check the count. Number of factors is 0. In previous case, we check the count is 2. In this case, we are checking the count is 0. If count is 0, then we can say that the given number is prime number. Children are getting. So in previous case, what I did here, it is in denominator part, I taken the value from 1 to 9. So in next step, say by applying some simple mathematics, so I removed 1 and itself. So 9 modulo by 2 up to so on 8. So 1 and itself, then count is equal to 0. The factors is 0. Then we can say that it is prime number, right? So previously there are 9 comparisons required. Now it is becomes to 7 comparisons. So next is you observe the simple mathematics. Yes, you observe the simple mathematics, children. If the given number is n, if the given number is n, so after n by 2, after n divided by 2, so there is no factors. For the given number, except itself. So children, are accepting this simple mathematical statement or not? Suppose if the given number n, suppose if you take the some number 8, so after, if you take the number 8, so after 8 divided by 2, so what is the result you will get? You will get the result is 4. So now, so in this series, so after n by 2, there is no factors for the given number n except itself, right? So except itself. Suppose if you find the factors for this 8, what are the factors? 1, 2, 4, 8. So what this mathematical statement is telling, after n by 2, there is no factors for the given number except itself. N by 2 tarvata, then factors undav except itself. Simple mathematics. So instead of doing, so this modulo division up to n minus 1, so what they suggested here is, they suggested up to you need to do only n by 2, right? So you need to repeat this loop for 2 to n by 2. 2 to n by 2. Half of this one. So next in the software industry, so what they suggested here it is, so no need to go for n by 2, you need to go for the 2 to square root of n, sqrt of n, square root of n, square root of n. So no need to go for this up to n by 2. So you need to check up to only 2 to square root of n. This is the logic where this industry is using frequently, right? So they are not checking 2 to n by 2. They are checking only sqrt of n, square root of n, right? So square root of n. So in this case, you are getting the time complexity square root of n, square root of n time complexity. So square root of n is less than this n by 2. This one. Now, so this is the strategy. So what they are doing, so in denominator part, first we are taking 1, 2, 3 up to so on 9. So next time, so what I am telling, however, a number 1 and itself is the factor. What is the need to check from 1 and itself? So you can check from up to 2 to n minus 1. So we did it. So next strategy, so simple mathematical strategy. For the given number n, after there is n by 2, there is no factors for the given number except itself. So we will check 2 to n by 2. So in the software industry, compared to n by 2, they are checking square root of n, sqrt of n, right? So this sqrt n is less than this square root of n, 2 to square root of n, right? So this time complexity we are getting. So children, so this is the basic diagrammatical representation of time complexities. If you take any algorithm, the algorithm must be fall any one of these categories. Suppose if it is fall into this category, you will try to reduce into its time complexities like its lower capabilities, right? So if you follow this strategy, so in the first class, I asked you to implement so this question. Yes, children. So which question? So write a Java program to find minimum and maximum, to find min and max, right? Minimum and max, right? Using brute force approach, brute force a trial and error version. So next is I'm asking the same question, right? So to find min and max, to find minimum and maximum numbers, min and max, using this divide and conquer strategy, D and divide and conquer strategy, right? So now if you take this brute force approach, children, so the brute force approach, so what we will do, so at least we need to take this for loop, right? So this for loop, the time complexity becomes to, here it is order of n, the time complexity becomes to order of n. Yes, already you are implemented this by using some loop, you are checking the values. Suppose if you use divide and conquer strategy, the time complexity becomes to order of log n. So similar to our binary search strategy, but in this strategy, so what we are doing, we are maintaining this find min max strategy. So we are maintaining two variables like so min one, min one, so max one. So min one. So next is max one. So these four variables we are maintaining, right? So in morning lab, I explained this program for batch 1 students. So this recording is available. Please look into it, right? So here I explained with program support for which batch 1 students, right? So with the time complexity becomes to log n. So previously it is order of n, this in this line, yes, this green line. So now if you make it is divide and conquer strategy, now it will comes under this line. So is it better or previous compared to this one or not? Yes, our strategy is we need to minimize it. So this strategy, right? So our strategy is we need to minimize it. Already it is running on this time complexity, so we need to minimize it. So in morning class, in morning lab for batch 1 students, I explained this strategy to find min and maximum element using divide and conquer strategy. So the time complexity here it is log n. So previously it is, if we go for previous strategy, order of n log n. So just I will share within 2 minutes, I will share this content with you, right? So children, so file open, yes, max and min strategy. So max and min Java program. So now I'm able to share my edit place. So children, so what I am doing here is simply by using this random function, I am generating some number. Random function will generate the numbers. So excluding 0, 1. Excluding 0, 1. This is, suppose if you are writing including 0, 1, you are writing a square bracket, right? So but here excluding 0, 1 means, so this is, So simply you studied this mass in 6th or 7th class, excluding this one. Including means in square brackets, right? Excluding means, so this open parenthesis and close parenthesis, right? So now here random function will generate the number between these two. So that is point. Yes, the approximate value is point. Suppose 2-digit number. So what we will take here, it is in I am multiplied with 100, then we will get a 2-digit number, right? So we will round up to upper bound. So here I'm taking some array. So I'm generating some numbers. So get max will return the maximum element. Get min will return the minimum element. So what is the strategy here? It is, children. So what is the strategy I'm using here? It is, so simply if you are taking the list of elements like you can take the list of elements like here. Yes, I'm taking the list of elements like 11. So next 9. So next is 22. So next is some 99 or 98. I'm taking the number like this. Assume that this 4 list. So what is here? It is, it contains 4 list. Then you need to divide into 2 parts. So mid is equal to low plus high by 2. Similar to our binary search, you need to divide. So from this list, you need to find the minimum element. So from this list, minimum element becomes 2. So what is minimum element? It contains only 2 elements. Just you need to compare these two. Minimum element is 9. So max element becomes to 11. Max element becomes to 11. So next is from this list, minimum 1. So min 1 becomes to 22. Min 1 becomes to 22. So max 1 becomes to 98. So max 1 becomes to 98. Right? So why are you maintaining? So this min 1 max 1 means, so we need to make a recursive call for this. This is one list. So this is other list. So this list will return min max. This list will return min and max values, but I am storing in min 1 and max 1. Actually, it is also returning min and max, but I am temporarily storing in this variable. Why means, so this min and max are overwritten by next list. From this, so children, so once you find min and max from list 1 as well as list 2, so next children, what you need to do here it is, from this min comma min 1, right, 2 elements, you need to find the minimum element, just simple comparisons. So which is the minimum? 9 and 22, so 9. So 9 is the minimum element, you can take it. So next max comma max 1, so 11 and 98, 11 and 98. So what is the max element? So max element becomes to 98. So from this 2 list of elements, you need to return. So max element is 98. From this min and min 1, the minimum element is 9. So here it is 9 and 98. If you are following this strategy, the time complexity becomes to order of log n, right? So I will I will clearly explain in the morning class, morning lab batch 1. So please look into that video whenever you are free. So this is, yes children. So the strategy is similar to our binary search strategy. If it contains only single element, the maximum or minimum element will becomes to this one. If it contains 2 elements, how can you know this 2 elements means? So I is low index, j is high index. I is pointing to low index, j is pointing to high index. If it contains 2 elements means 0, 1. So I value is 0, j value becomes to 1. So now I is 0 is equal to 0. Then in this case, if 2 elements are there, simply you need to compare these. Right, only 2 elements, then you need to compare these 2 elements, then you will get min and max, right? So next, if it is contains, the list contains more than 2 elements, then we are finding mid is equal to low plus high by 2, similarly I plus j by 2. So after this one, what we need to do? Yes, we need to make a recursive call. So low to mid plus 1 to high. Yes, so similar to our binary search. So here also I'm making a recursive call. So low to mid plus 1 to high. But the strategy here it is, once you make this recursive call, it will return the element max and min. You are storing these values in variable min and max 1. Why means, so the second one also is returns min and max. Once this function is completed, it is also written min and max. But previous values are overwritten. To avoid it. So what I am doing, so min and max values I am storing in max 1 and min 1. So first function return calls, first recursive call return some values. So I am maintaining in the variables max 1 and min 1. So second one also returns some values max and min, so which are different from the above. So here these values will be stored in the min and max. So now what I need to do, yes, I need to compare min with min 1 So min 1 already this first function is returning. So this function is returning min. So we are comparing. So max 1. Now if max is less than max 1, if first this function is returning some value, is returning max 1. So the max is equal to max 1. We are writing, right? So here max 1 value is greater than this one. So we are finding from max 1, max and max 1, we try to find what is the maximum value. Here, this is simply by using simple if. So if min and min 1, what is the minimum value? If min is greater than min 1, so min is equal to min 1. So simply we are writing this strategy, combining the solutions. So what we are doing, we are dividing, but we are taking the min and maximum elements from the list. So this will come under order of log and time complexity. So in morning class, I explained these concepts, right? So now this program is running already. So I shared this program with the learning portal. Please, whenever you are free, you can look into it, right? So next, this, yes. So what we are discussing, yes, we are discussing about these algorithmic strategies. So what are the different algorithmic strategies? So brute force. So already I told that is to find the minimum and maximum using the brute force. So next is I told this minimum and maximum using divide and conquer strategy. Right. So one more problem you can do it here it is. So I asked to implement this Fibonacci sequence. So Fibonacci, children, Fibonacci recursive implementation. So implementation, Fibonacci sequence recursive implementation. How many people did this one, children? Yes. So Fibonacci recursive implementation, I asked to implement. How many people did this problem? Yes, children, please speak out. Yes. Children, are you there? How many people implemented this Fibonacci recursive implementation? Janardhan, Ritika, Nivedita, Reddy, Vaishnavi, Vasu. Okay, if you are not implemented, there is no problem. Already I will share the content with you, children. So there is no problem, right? So even though if you are not implemented, I will share the content with you, right? So before going to this recursive implementation, already you know the series, yes. So we will take some problem here, children. So now I will share my content here, you share. So simple, we will take some simple mathematics here. So children, so now this is permutations and combinations, prastaralu, samyogalu. You are studied in 5th or 6th class, na? 7th class. NCR, NPR, NCR. NCR is equal to n factorial by r factorial into n minus r factorial. So where NPR is equal to n factorial by n minus r factorial. So now you take this problem, simple mathematical problem. Yes. So now children are able to see my screen. Yes, please. Yes, children are able to see my screen. So you take the question. The question here it is, you are given n plates. Actually, there are n plates. So you need to keep roses in plates. Children, are you able to see my Word document? Please respond. Are you able to see my question?
Yes.
Yes. You are given n plates. You need to keep the roses in plates, right? So there are two types of roses. One is white rose and one is red rose. You have unlimited supply of roses. How many roses are there? There is unlimited supply of roses. Suppose this here, you are given n plates, n value is 100, one is less than or equal to n is less than or equal to 100. So now what we need to do, so given n, how many different ways are there to arrange the roses so that there are no two red roses are together. So what is our intention? So actually there are two types of roses. What are that roses? So red roses and white roses. From these roses, right? So what we need to do? Yes, we need to arrange the roses in the plate. So the condition is that there are no two adjacent, that there are no two red nodes are adjacent here. So now the condition is that there are two. Yes. So here given n, where n is number of plates, you are given n plates, you need to keep roses in the plate. How many roses? Yes, there is infinite number of roses. Two types of roses. The types of roses is white and reds. So you have unlimited supply of roses. So the condition is, so how many different ways are there? There are to arrange the roses that there are no two red roses together, right? So for this, simply you can take n is 1. the number of ways. So here that there are no two red roses are adjacent. So red rose and white rose, you can put this. Suppose if you are taking n value is 2, n value is 2. So that is we can take white combination, white red combination. So red white combination and red combination. But the constraint is there is no two red roses. So if there is red and red besides, then you need to cut it. Yes, I cut it. Red and red is there, I cut it. Suppose if you take n value is 3. So what are these different ways? So this is, you can take W as 0, R is 1. So this is binary number representation, 0, 0, 0, 1. So triple zeros, 001. So next 0, 1, 0, 2 representation 3, right? How can you write this? How can you repeat this combination means? So you need to write binary number representation. So now once you wrote this binary number representation, W indicates 0, red indicates white, 1, R indicates 1. So W indicates where W is there, 0, 1 indicate, R indicates 1. So if there are two consequent red nodes, you need to cut it. Here triple R, 1, 1, 1, you need to cut it. Here RR, you need to cut it. So you need to you need to count these ways, 1, 2, 3, 4, 5. 5. Here there are 5 ways. Suppose if you take four rows, the combinations is W, then you will getting this series 8. So now once you make this ways, different ways, once you make the observation 2, 3, 5, 8. So 2, 3, 5, 8. So next 2 plus 3, 5. So 3 plus 5, 8. So 5 plus 8, 13. So you will get a series. Yes, children. So once you make this observation, so this number of ways, it will generate a series. So which series means, so the previous two numbers is, it will becomes the next number, right? So the previous two numbers, it will becomes to the next number. So where it is possible, yes, this is a combinations and permutations you can take. Here it is. You are given n plates. Actually, there are n plates, right? So you need to keep rows in plates. Here number of n is number 1, 2, 3, 4, right? Plates. So now you need to keep rows in plates. Two types of rows, actually white and red rows. You have unlimited supply of rows. So now how many different ways are there to arrange rows such that there are no two red rows together? Red rows, if there is together, then you need to cut it, that combination. So from this, if red and white, if you are taking one red, one white, then two combinations, two ways. If you take some this two plates, then so we can take the combinations from first plate to white, second plate to white, so white, white. So from first plate to white, second plate to red, so white, red, these combinations. So from first plate to red, second plate to red, there's two, this red two are together, then it is not acceptable. So these three are acceptable, this red, I cut it. So three ways. So similarly, if there are three plates, you need to pick up a red and white. So you can pick up like from first plate white, second plate white, third plate white, some first plate white, second plate white, third plate red. So but this is not possible. Triple reds are two continuous reds. This is not possible. This 5 ways. So once we generated this ways, once you keenly observe this ways, so it is generating some sequence. So 2 plus 3, 5, 3 plus 5, 8, 8 plus 5 plus 8. Next the solution is 13. Next solution is 13. So it is generating a Fibonacci sequence. So the Fibonacci sequence is nothing but fib of n is equal to, so the previous two terms, fib of n minus 1 plus fib of n minus 2. The initial conditions, what we need to take here it is, so initial conditions, f of fib of 0 is 1, fib of 1 is, you can take either these initial conditions. So you are implemented this Fibonacci sequence now, right? So now we are implemented this recursive Fibonacci sequence, children. I think you are able to see my edit plus. So class recursive Fibonacci sequence, right? So here I'm defining my fib sequence. So I'm passing some long n number, right? If n is less than or equal to 1, return 1, return n, there is no problem, n value. So else return fib of n minus 1 plus fib of n minus 2. In order to get fib of n, so what we need to do, yes, we need to add the previous two terms, fib of n minus 1 plus fib of n minus 2. So this way, so we are trying to find the Fibonacci sequence in our series, right? So I implemented this program, yes, Fibonacci sequence. So next in main method, what I am doing here it is, just I am calling this Fibonacci sequence by passing n value is 5, right? So that it will generate the first 5 Fibonacci series, first 5 numbers in the Fibonacci sequence, right? So here simply it will generate the fifth number. Yes, fifth number in this Fibonacci sequence it will return. So that we will print it. So fifth number in this Fibonacci sequence, right? Suppose here fib value is 0. Initially fib value is 0. Suppose n value is less than or equal to 0. So here in this case, so what we need to do here, it is children. So you take this code. Yes. So you take this code class Control C copy. So children, please I will go Control V paste. Control V paste. So now children, please you keenly observe this code. So once you observe this code, what we are getting here, it is children. So now I written the code here. So we are taking the Fibonacci initial conditions. So fib of 0 is if this value is 0, then 0. Fib of 1 is 1. These are the initial conditions. So you can take it, right? So next is fib of 2 is f of fib of 2 is the combination of fib of 1 plus this one, 0 plus 1, 1. So next fib of 3 is next previous two terms, 1 plus 1, 2. So next fib of 4 is equal to previous two terms. So 1 plus 2, 3, right? So next fib of 4, 5 is equal to, so now what is the term? 2 plus 3, 5. So fib of 6 is equal to, right? Fib of 6 is equal to, so 3 plus 5, 8. So next to 13, you are getting this Fibonacci sequence from that mathematics, right? So now we will try to implement this. If n value is, so here I'm passing n value is 5, then fifth series in this Fibonacci sequence, right? So what we need to do, yes, I want to run this program. For that purpose, I open this command prompt, cmd, command prompt, right? So next, where I saved this program, I saved this program in my home directory. Children, please look into my home directory. So where is my home directory? So in desktop, da folder. Yes, children, desktop. So da folder. So da folder programs. So da programs. So this is my home directory. So in this, I go for this address bar and copy this address. Yes. So I'm pasting command prompt, Control V. So I will share my command prompt here once again. So children, so what I am doing here it is, so I'm sharing my command prompt. What I did here it is, just I go to my home directory from the address bar, I paste this address. This is C drive users version desktop da programs. This is my my program is stored. So cd space change directory this particular location. So after went to here, so what we need to do, yes, you need to compile your program Java C Fibonacci sequence, recursive Fibonacci sequence, yes. So recursive Fibonacci sequence.java. So compile it. Already I tested, so I will get 0 errors. If you get 1 or 2, you need to debug it. So recursive Fibonacci, Java C space file name dot extension compilation. So running is Java space file name. So now the fifth sequence in this Fibonacci sequence is, yes. So the fifth number in this Fibonacci sequence is this one, right? So this is f of 5 is 5. Suppose if I am calling this with suppose n value is 30, I want to know. So the 30th number in this Fibonacci sequence. Yes, I want to know the 30th number in this Fibonacci sequence. I change this n value is 30. When there is a big number, then your program will scalability problems will be raised. So Java space big number. Suppose if I am changing this Fibonacci sequence value is some 50, 32, some 50, 55. I change it, n1 value is 51, 55. Again, I'm compiling. So just I'm running this program. Yes, in order to generate this number, the system is taking so much time. Yes. So in order to generate this number, you make one observation. So in order to generate the 55 term, 55th term in the sequence, it is taking this much time. After 5 minutes or 10 minutes, it will use the result. So why the system is taking this much time? So that is the problem actually. Yes, children. So it is taking this much time. Why the system is taking that much time? So that is the problem, right? So anyone can tell why the system is taking this much time in order to evaluate this 55. 55 series in this Fibonacci sequence? Yes, children, anyone can tell, please. Yes, please. Children, anyone can tell why the system is taking this much time in order to generate the output for 55? Yes, please. Yes, so that is the main drawback of this divide and conquer strategy. Yes, in the divide and conquer strategy, so what they are doing here it is, so they are, the sub problems are overlapping sub problems. In DI and SC strategy, the problem is overlapping sub problems, overlapping sub problems, right? So I'm giving only overview, right? So in order to address this problem, so overlapping sub problems. So there is a scientist name is Bellman-Ford, right? He is told to be father of this dynamic programming. So father of dynamic programming. So what he told simply, so no go for this, no overlapping sub problems. It does not have overlapping sub problem. If the problem is divided into sub problem, if sub problem is computed once, if sub problem is evaluated once, so no need to evaluate again, no need to evaluate again and again, right? So what they need to do, just they need to, the value they need to store and use it. So in order to store these values, simply suppose simple in one value, then we can use variables. If it is a collection of variables, then we can use arrays, right? It is a group of variables, then you need to use arrays. If it is single variable, then you need to store in some index variable. Suppose if it has some 10 or 20 variables, then you need to use arrays into some X array, right? So new int of this one. So by using these variables, suppose if it is a single variable, so you need to store in the variable. If it is a collection of variables, you need to use in the arrays. So this concept is invented by the Bellman-Ford. So this concept is said to be the drawbacks of divide and conquer strategy. This is the main advantage of dynamic programming. So the father of this dynamic programming is Bellman-Ford. What he told that if there is any overlapping sub problems, so no need to evaluate again and again. So once it is evaluated, then you need to use it, right? Yes, you can take this. Suppose if children follow the, suppose if I want to evaluate some f of 5, so fib of 5, so what is this? Already we taken this initial conditions, f of 0 is 0, so this f of 0 value is 0, so these are the initial conditions. F of 1 is 1. Yes, children, f of 0 is 0, f of 1 is 1. So if you take these initial conditions, so what we are doing here, it is fib of 4, fib of n is equal to, yes, already you know the series. So fib of n is equal to, so the sum of last two terms, fib of n minus 1 plus fib of n minus 2. So fib of n minus 1 plus fib of n minus 2. Fib of n minus 2. So from this formula, so what I am doing here, it is fib of 5 is a combination of fib of 4 plus fib of 5, fib of 3. So next, how this fib of 4 can be expanded? So it can be expanded as f of 3 as well as f of 2. So now f of 2, right? So now this f of 3 can be again expanded is f of 2 comma f of 1. So this f of 1 value, you know, yes, you know this f of 1 value, that is 1, it will return 1. So again this f of 2 is expanded as f of 1 comma f of 0, f of 1 comma f of 0, right? So now again you need to check into command prompt whether you got the result, not yet. So now again, this f of 2 can be expanded as f of 1 and f of 1 and f of 0, right? F of 1 and f of 0. So next this f of 3 can be expanded as f of 2 comma f of 1. So this much big tree, yes, f of 2 comma f of 1. F of 1 value, you know, this f of 2 again it is expanded as f of 1 and f of 0, right? So this is expanded like this. So next f of 2, f of 2. So this is the expansion will takes. So once it is completed this much big tree, so you need to evaluate how many times each and every variable is evaluated. F of 5 is evaluated 1 times here. F of 4 is again evaluated only one time. F of 4 is appeared only one time here. So f of 3, how many times it is expanded? F of 3 is expanded here one time, here second time, two times. Yes, f of 3 is expanded two times, children. So next, so f of 2, yes, once you observe this f of 2, so of f of 2, how many times it is expanded f of 2? So look into here, f of 2, f of 2, f of 2. So f of 2 is expanded nearly 3 times, right? So if you take only f of 5, this much tree is expecting. Suppose if you are taking f of 55, so how can you make it is 54? So this is 53. So which we can expect a huge tree. We can expect it a big tree, a very big tree. So for that purpose, it is taking this much time, right? So your system is, in order to generate the result, it is taking so much time. So for that purpose, what this Bellman Ford suggested, suppose if you are evaluating this one, f of 2 is evaluated here. How it is? F of 0 is 0, f of 1 is 1. So now f of 2 value becomes to 2. So when f of 2 is there, no need to expand it. Just you need to save it and you need to use it, right? So f of 2 is there, no need to expand it. Just you need to save some variable, use that variable to hold this, retrieve these values, right? So that is the beauty of this dynamic programming. So here the question is, what is the beauty of this dynamic programming means? So there is no overlapping sub problems. In divide and conquer strategy, it is suffer with overlapping sub problems, right? So the same strategy. So here, even though if you are not getting the output, if you are giving the 55 as the input, then what they suggested here it is, here you need to take the same program. So if you are evaluating something, then you need to use it, no need to evaluate again and again. So this is dynamic programming. This concept is invented by the scientist name is Bellman Ford. Children, is it clear? Ardhamainda? Pillalu? Children's? Yes. Shivatmika, Snigdha, Shruti, Pujita, roll number 8. Yes. Vriddhi. Children, Janardhan, Karthik. Children, are you following? Pillalu, follow అవుతున్నారా? Yes, please. Anyone can respond. Yes. Some people has responded. Yes, yes, Janardhan. Yes, good. Good. So this is the third algorithmic strategy, that is a dynamic programming. In greedy approach, we will try to find always the best optimal, whether it is minimal or maximal or minimal. So we will try to find the best strategy in the greedy approach, right? So first of all, so what is our intention? So if you take any algorithm, it must be follow any one of these categories. So what are the different categories we have? Brute force approach, divide and conquer strategy, dynamic programming, greedy approach. So some maybe it is backtracking. So backtracking with branch and bound conditions. At the end of this total subject, so we will study some of the algorithms. So the algorithm will be, we will try to identify it will comes under which strategy. So next, if possible, we will try to minimize it, optimize it. Yes, whether we can reduce, we can optimize it. That is, number of steps are the time required to evaluate your algorithm is minimum. Else, we will try to make your profit is best. Suppose if you get some profit, so you will try to make it is the profit is best. So this is the entire DAS objective. So once you understand this, yes, I'm not going to the next topic. Why means after 1 month, 1 month of time, then we will start again, right? So now I will list out some algorithms which are comes under which you will tell, right? So first of all, I will make this algorithmic strategies. Then I will read some algorithm. You tell. So which algorithm will comes under which strategy, right? So now here, this one, yes. So I will insert. Yes, children. I will insert one table. Insert one table. So which table I want to insert? This table. Okay. So now I want to write some algorithmic strategy. So first one is brute force, right? So brute force. So next one is divide and conquer. divide and conquer. Next one is dynamic programming. Dynamic programming. So next one is this greedy approach. So next one is backtracking. Next, backtracking with branch and bound conditions. Backtracking with branch and bound conditions. With branch and bound. So next one is here this algorithmic strategy. Yes, children. So I will read some algorithm. You tell which algorithm will comes under which strategy, right? So next one is branch and bound. Next one is NP hard graph problems. NP non-polynomial. So what is polynomial means? So up to n cube. Non-polynomial means it cannot be solved in polynomial type. NP hard. We will discuss. Okay. So I will read some algorithm. You tell which algorithm will comes under which strategy. Binary search. Binary search where it will comes. Children. Yes, please speak out. Binary search will comes under binary search will comes under divide and conquer strategy. Linear search, brute force, right? Linear search will comes under brute force, a trial and error version. So next, bubble sort, selection sort, insertion sort, bubble sort, bubble sort. Next, selection sort. Next, insertion sort. Next is finding minimum and max. Find the min and max. Min and max in a given list. Max element. Okay. So now, so can you tell some of the algorithms? These are the comes under brute force, trial and error version, exhaustive methods. So next, can we make this find minimum and max under divide and conquer strategy also? Yes. So we can comes under this algorithm. This algorithm can comes under, we can solve by using divide and conquer strategy also. The time complexity here becomes 2 order of log n, right? So previous case, here it is, if you solve this problem using this brute force approach, time complexity becomes 2 order of n, right? So now, can anyone can tell merge sort, heap sort, merge sort, next heap sort, this one, quick sort, quick sort, right? Next heap sort, right? Heap sort. Next is Stressels matrix multiplication. So last class I told na Stressels matrix multiplication, right? So next is Stressels matrix multiplication. Next, some advanced algorithms are there. So these are the known algorithms: heap sort, Stressels matrix multiplications, right? So next, dynamic programming. Can you name some of the algorithms which will comes under dynamic programming? So now it is multi-stage graph, right? So next, all pair shortest path problem, all pair shortest path problem, right? So next is single source shortest path problem, source shortest path problem, right? So next is OBST, optimal binary search tree, right? So next one is 0/1 knapsack problem. Next is a reliability design, design. So next is a traveling salesperson problem. Next is in greedy method knapsack problem. Yes, knapsack problem here, knapsack problem. So next, job sequence with the deadlines. Okay, we will discuss these problems once we are started again. Job sequencing with the deadline, right? So next is this minimum cost spanning trees. Minimum cost spanning trees. In this, we will go for this Kruskal algorithms and Prim's algorithms. Prim's and Kruskal's. Right. Minimization. These are greedy approaches. Minimize and maximize. Right. So these are the basic problems we will discuss once the syllabus is started. Right. So next, can you name some of the algorithms which will comes under backtracking? 4 queues problem. Yes. So 4 queues. So 4 queues I explained in one case. Right. So there is no attack and at the row wise or column wise or diagonal wise 4 queues problem backtracking. So next is 8 queues, 4 queues, 8 queues, graph coloring. Right. So next is backtracking with branch and bounds. So we will comes under least cost search. The 15 puzzle problem. Okay, 15 puzzle problem. So next is here FIFO branch and bound. First in first out FIFO branch and bound. So next is 0 by 1 knapsack problem. 0 by 1 knapsack problem. Problem. Right. So next is NP hard problems. So which are comes under NP hard means chromatic number. So chromatic number problem. Chromatic number detection. So what is chromatic number? You studied in MFCS, Mathematical Foundation of Computer Science in last year. So graph coloring. So the minimum number you required here. Hamiltonian cycles. Hamiltonian cycles. Right. So next to traveling salesperson problem, TS, traveling salesperson problem, TSP. So this problem is comes under previous. Yes, it will comes under in previous, but here it is getting some time complexity point of view different. We will make it is optimization. So these are the different problems which will comes under. So now once you make observation, this finding minimum and maximum element, so we can solve in brute force as well as divide and conquer strategy. Here time complexity is order of n. Here the time complexity is order of log n. Right. So this is the strategy. Right. So in this we will try to make our solution is best. Right. In this way we will try to make our solutions are best. Okay. Any doubts in this children? Yes. So just I list out this algorithmic strategies. So which problem will comes under which one? So now once you studied this one, so this will becomes to first unit, this will becomes to second unit, this will becomes to third unit. Nothing is there, right? So now once you studied this one, so each and every unit we will study some of the algorithmic strategy. In this algorithmic strategy, which will comes under, right? So children, yes please. Yes please. Yes. Yes, 36 Kaushik, are you there? 36 Kaushik. Yes, children. Any doubts in this? Yes, what is your fourth period? SED? Rakesh sir. Yes, please speak out. Yes, rule number 1. Yes, rule number 1. Please respond your roll call.
Sir, I'm there.
Yes. What is your fourth period? Rule number 1.
1 second.
Just anyone can tell. Rule number 2 or 3, 4, 5.
ACD, sir.
ACD. Automated and compiler design. Okay. Rakesh sir, kada?
Yes, sir.
Yes, thank you. So select all. So now please respond your roll call. Today is 11 by February, 11 by 2. Yeah, 1, rule number 1. Yes, present. 2.
Yes.
3. Absent, 3 absent. 4. Absent, 5.
4 present, sir.
Present.
5.
5 present, sir.
6. 6 present. 7. 6 absent. Okay. 7.
Present, sir.
8.
Yes, sir.
Yes. 9. 9 absent. 10.
Yes, sir.
11.
9 present, sir.
Okay, I will come once again. Those people who are absent. 11. 11
Present,
absent.
sir.
Okay. 12.
Present, sir.
13. 13 absent. 14.
Present, sir.
15.
Present, sir.
16. 16
Yes,
absent.
sir.
Yes, present.
16
17.
present, sir.
17.
Present, sir.
18.
Present, sir.
19.
Present, sir.
20.
Present, sir.
21. 21.
Present, sir.
22.
Present, sir.
23.
Present, sir.
24.
Present, sir.
25.
Present, sir.
6.
Sir.
26 absent. 27.
Present, sir.
28. 28 absent. 29.
Present, sir.
30.
Present, sir.
31.
Present, sir.
32.
Present, sir.
33. 33 absent. 34.
Present, sir.
35.
Present, sir.
36.
Present, sir.
7.
Present, sir.
8.
Present, sir.
39.
Present, sir.
40. Absent. 41.
Present, sir.
42.
Present, sir.
43.
Present, sir.
44. 45.
Sir, 45 mic not working.
Okay. 46. 44 absent.
Present, sir.
He
Okay.
kept in the chat box.
46.
46 present, sir.
47.
Present, sir.
48.
Present, sir. 48.
49.
Present, sir.
50.
Present, sir.
51.
Present, sir.
52.
Present, sir.
53.
Present, sir.
54.
Present, sir.
55.
Present, sir.
56.
Present, sir.
7. 58.
58 present, sir. 58 present. 58 present.
59.
He kept in chat box, sir.
60.
Present, sir.
61. 301.
Present, sir.
2.
Present, sir.
3. 3 absent. 4.
Present, sir.
5.
Present, sir.
6. 306 absent. 181.
Present, sir.
1940.
Present, sir.
Sir, 33 present. He just now got disconnected.
Okay, just
Present, sir.
I will
28
read
present,
the
sir.
numbers. I will read the numbers. Please look into it. Yes, the absentees are 3. Are any ready? Are you there? Okay.
Yes, sir.
6. 6. 9.
Sir,
13.
6 is present, sir. She cannot unmute.
Okay.
13.
9. 13. Okay. 26.
In the chat box at 26.
Okay. 28. 33.
28 present, sir.
33 present, sir. He just
Okay.
now got
40.
disconnected.
40.
Sir,
40.
9, she's present. She's unable to unmute herself. 9 is
40.
present.
40.
Sir, 40 present, sir.
57.
Present, sir.
57 is there, sir.
303. 306.
303 present, sir.
Okay.
So he's-
306.
Sir, roll number 9 present, sir.
Okay. 306. Only one absent. Thank you. 306. Control S. Stop share. Stop share. Stop recording.